Wilson, and this is the A-star implementation of the eight squares problem. So here I have some familiar methods from the previous time that I solved this, where I have the setup array and is solvable methods that just make sure that I create a solvable array. I also have a get index function that basically gets the index. I have a Manhattan function that calculates the Manhattan distance for any value that I give. And then I have a calculate h, which calculates the h a of the like board of the current board and the goal board. Um, so here in my solve board method, I start out by setting a few things, basically making sure G is 0, setting the F of the board, making a queue, and making a visited states list. Apologies, it's late. This visited states list will make sure that I am not repeating previous states. So in the main chunk here, um, I have a while loop, which basically goes through, keeps going until we hit the goal, and it adds 1 to G, and then here it prints out what the current board is. That's what you're seeing down here as it's running. And then here is an improved method that basically adds new moves in. We have all the possible moves down, right, left, and up. And here in move space, it tries to see if it can move to the given space, and if so, it creates it changes the space and it swaps the spaces that need to be swapped and then returns the board. Otherwise, it returns none. So in this, sorry, move past it. We try to create a new board, and as long as it is not a board, as long as the board does exist and we have not visited it yet, we then add it to the queue, and then we try to find the best board. We have an impossibly high number here, and then for each state we find essentially the lowest state by iterating through every single state that is in the queue so far. And then we then keep iterating through and updating the current board until we reach a state that has um, the answer. So if any of these states, the state at 0 is the depiction of the board is equal to our goal board, we then return the state. And then if it doesn't happen there, we also have it down here that it returns the current board once it exits the while loop, which is when current board is equal to the goal board. So yeah, this get number is a leftover from the previous what's it called, implementation. And here we have the main operation, where basically we have a start time. I need to implement a end time to print at the end of this, but it goes through the array. It sets up the array that needs to be solved, and then it has final array be empty here. so that when we set it equal to the solved board and print it out at the end, it will be the actual answer. So I'm gonna just sit here for a second and wait for this program to finish.